For question number 5, we want to use the improved Euler's method to approximate the solution to the following initial value problem. The derivative of y with respect to t is equal to 3y minus 1, with y of 0 to be 4, and t being between 0 and 2 inclusive, h being 0.5. So this is already solved for the derivative of y with respect to t, so we're good with that. This we'll use for the interval that we have of 0 and then 2, again with no comma between these. Since our step size is 0.5, this corresponds to 2 minus 0 divided by 4 to give us a value of 0.5, which implies that n in our code has to be 4. The Matlab code that corresponds to this is new Euler. Then in parentheses we have 0, 2 in brackets, comma 4, comma 4. And this 4 is based on our initial condition of 4. Just to see this in Matlab, let me open that up. So the program that we are using is this new Euler program. Let me just get rid of this graph. And once again, just like with the Euler function, we need to put our equation in here, which was given as 3y minus 1, which I wrote here as 3 times y minus 1. And we need to then use that in our code. So this is going to be new Euler. And we're going to open up parentheses, and in brackets, we are putting 0, space 2, closing the bracket, comma 4 from our initial condition, and then 4 for the value of n. Doing so gives us this. So we have our values of x down here, and then we have our values of y, which, as we could see, kind of starts increasing here without bound. One of those unfortunate problems when it comes to the, well, this is the improved Euler's method, but it still has its own problems, as we could see in this case. And this is just the graph corresponding to that, showing that increasing without bound. Just to write out that solution then as a table, so we have a value of x, and these were given as 0, 0.5, 1, 1.5, and then 2. Our values of t, which will be basically just that step size of 0.5 for each value. I'm not going to write all those out. Then our values of y. For 0, it was 4. For 0.5, it was 13.625. For 1, it was 48.5156. For 1.5, it was 174.9941. And for 2, it was 633.4788 as the solutions that we got from the output. Thank you.